last lesson, we looked at dynamically allocating memory when we need it at runtime. Basically, if we need more memory for a particular reason at our program while the program is running, we have functions in the standard library that we can use to add additional memory, or rather get additional memory. But one thing that we want to take a look at is making sure that those functions work properly. So there are cases where you could run out of memory, and we want to know exactly what that return will look like and how we can handle that in our program. So in the same way that we were looking at allocating memory, let's set that up again. So depending on how much memory you have and depending on the operating system that you're running this code on, it'll actually make a difference on when you actually run out of memory. So we're not going to look at a real-world example of running out of memory, but it's definitely something that you want to keep in mind. When you go to get more memory with one of the memory allocation functions that we looked at in the last lesson, we have to make sure that the memory is there first, that we have more memory available to allocate. Because our program might need to behave differently or even not be able to continue executing if we don't have the memory available needed. So let's write a simple call to the memory allocation function. So now we've tried to allocate basically the size for 10 characters into this new character variable. But we want to make sure that the memory actually got properly allocated. If it didn't, it'll return a null pointer to us, and this actual variable that we've created will actually be null. So every time we make a memory allocation call, we want to sort of check it in this way. Or actually, we can check either the positive or negative condition depending on how you want to handle this. But so basically, it's important to remember to check if your memory actually got allocated. There are cases where you can run out of memory in your application, and if you have something that's heavily dependent on a certain amount of memory being available, you don't want to cause other issues with your program or attempt to continue executing code that isn't going to work properly. So this is how you can tell if the memory that you've attempted to allocate hasn't been allocated properly. So make sure to always check for null pointers when you're allocating memory. So in addition to not having memory available, there's another case that you might want to handle. Say you have a variable and you've allocated a certain amount of memory for it, and you need more memory. You determine that you actually need more memory than what you've initially allocated at runtime. So there's a new function that we can actually use that will do the work of taking the old data that we had and copying it into the new memory that we're allocating. We generally use this for allocating larger space. So if we need more space, this function will take care of copying our old data to this new space, but also having the additional space that we've asked for. So let's take a look at writing a small example using this function. So basically we can start with this same string variable. And now we're not going to check for null pointers here, just for example purposes, we're going to add some data to this string. So we're actually going to use some functions from string.h here in order to copy directly into the string, keep the pointers the same. But all we're going to do basically is add some data to the string. So we're going to need the string header. And basically we can copy data in like this. So this will set the value of our new string to our initial data. So now we have our string that holds our initial data. But say we realize that we want to store more characters in this string. So we have access to this function from the standard library called reallocate, which basically works the same way that memory allocate does, except it will allocate new memory and copy all of the bytes from our old pointer, essentially, to our new data location, and extends it based on how much new memory that we're going to need. So we have to pass it our original pointer and the size of the new memory location that we need to allocate. So first we pass it the pointer, then our new size, and let's leave space for, say, 50 characters this time. So now we have our old data plus some extra space that we can use. So now we can concatenate new string data to this existing string data using the strcat function. And all that'll basically do is the same as doing one string plus another string. We're going to add some new string data to our old string data since we have more space for it now. So now that we've done that, the only thing left to do is print out our string so we can see the effects of adding the data. And that should be it. You should, when we compile and run this, you'll be able to see that the original data that we stored in our string, we copied to it, will still be there, in addition to the new data that we're adding with strcat. So reallocate allows us to add more memory, and we'll keep the additional data that we had stored in the original pointer. So now we can compile and run this. So as you can see, we have our initial data there and the additional string data that we decided to add later. So you can use the reallocate function in cases where you might need to add additional memory or you run out of space in something. So there's one more function we want to talk about that's available in the standard library for memory allocation. Basically, in really large programs that stay running, after you're done with a piece of memory, you're going to want to be able to reuse it, or basically indicate that you're finished with it. So in the standard library, there's a free function which basically, exactly what the name implies, frees the memory for reallocation elsewhere or use for something else. So we don't need to use free at the end of our program, because after our program is finished running, the operating system essentially frees all of the memory that that program was using. But there are some specific cases where you want to use free to use the memory that you've allocated for something else and basically set it as available for use again. So we can just look at the syntax, how we would use that function, but we're not going to quite yet get into examples where it's absolutely necessary. So basically all we need to do to free a particular section of memory is call the free function on the pointer that we want to free. So in this case, while, like we just talked about, we don't need to call free for this, just as an example, We could use the free function in this way to free up the memory that's been allocated for this new character variable, and then we could reallocate it to something else. So that memory would become available again for use in our program. And basically that's the syntax of free. So this function, free and reallocate, are two other important functions when we're dealing with memory allocation. And they might not be too important for the example programs that we're looking at, but as you build larger applications with C, maintaining control over how the memory is managed becomes very important.